Good morning, students. This is Professor Golding. Thank you for joining me again today. I have a very short video for you because I want to clarify some simple concepts about encoding symbols for display on a console screen, or the symbols and encoding that's used to bring in characters off of a keyboard. The reason this is important to mention very briefly this morning is because I see on examinations students often will make a mistake and miss an easy question. So the question that I wanted to ask you is, what are the binary bits that are sent to a console screen which result in the number 9 being displayed? It's a pretty simple question, and yet it's amazing how easy it is to get the answer to that question actually incorrect. So let's make sure we don't do that. And so first I want to say, if you answered the question, is this what your answer was? You can answer it in this case 7 bits, you could do it in 8 bits, you could do it in 16 bits, depending on the register size of the display or the keyboard. But at the end of the day, all of those answers would be the same, and that is, they're incorrect. If you answered 000 and then 1001, as I've displayed here, that would not be telling the display to paint the character 9. That's actually the encoding of an unsigned binary integer that evaluates for us as humans the number 9. Using place value, we have here a 1, and then no content or no quantities for the 2 and the 4 position, and then a 1 in the 8 position. So it evaluates as 9, as we know. So, but that's not what your keyboard is sending into a computer when you press the 9 character, and it's not how a 9 character is displayed. Because displays don't evaluate magnitude. They're not interested in the magnitude quantity that you, as your human brain evaluates things, associate with a symbol. Displays just paint symbols. So they can paint letters, they can paint what we know as numbers, they can paint special characters, etc. So displays are just interested in, what do you want me to paint? And keyboards are just interested in telling you, the computer, what symbol you actually typed on the keyboard. It's the ASCII codes that tell the console device what symbol to display, and similarly the ASCII codes tell the computer what key on the keyboard you actually pushed. So let's just take a quick look at the ASCII codes. And this is the very traditional ASCII code table. There are 128 symbols here that are being indicated in this table. And what the table can be interpreted as is what is that symbol represented as or encoded as in a variety of formats, decimal, hex, or octal, which ultimately at the end of the day, any of those would get converted into the same binary stream. So for example, if you looked at the capital letter A and wanted that displayed on the display, you would have to send in to the display a binary word that translates the hex value of 41. So the binary stream that would be sent to display would be, if it was an 8 bits, for an 8-bit register, it would be 0, 1, 0, 0 as the leftmost bits, and then the rightmost bits would be a 0, 0, 1. So this is essentially can tell you very quickly, looking at the hex column especially, what the binary stream is. Now, since there are only 128 symbols, you only really need 7 bits. But nobody's going to build a 7-bit register. Normally you'll see that registers are 8 bits or 16 bits, etc. But the ASCII table only requires 7 of those bits to encode. And let's just take a look at it in a little bit more visually easy form. For the number 9, if we looked at that symbol in the table, this is what we would see. 57 is the decimal representation of that 9, or 39 in hex. I find is the easiest to look at because hex is very easy to translate into binary. So in decimal or in binary, 39 ends up becoming 011 down here if I show that, and then the 9 would be 1001. So what the display needs to get out of its register or see in its register is these 7 bits. Hex 39, and then it says, oh, okay, and it will display this symbol, which has no meaning to the display whatsoever. It does not interpret that as being a quantity 9 that we as humans associated with that symbol. And then if I wanted to print out the symbol here, which is a colon, I'd use the binary stream that results from 3A, or the hex value 3A would be translated into binary, which I have done right down here, 0, 1, 1, 1, 0, 1, 0.